Have you ever wondered that what type of study deals with the changes occur in Earth's surface? It's geomorphology, the science which deals with the changes in Earth's surface and processes which develop them. Today we are going to explore the interiors of the Earth's surface. The three major layers form the interior structure of the Earth, which is further divided into several layers based on the chemical composition and mechanical composition. Now, question arises that how we know what lie beneath the Earth's surface. Actually, there are two types of sources, the indirect sources and direct sources. The sources which directly help us are mining, minerals we extracted from the depth, volcanic eruptions, the magma which erupted can be used as a laboratory analysis, deep drilling projects like Deep Ocean Drilling Project, Integrated Ocean Drilling Project. There are also indirect sources. Temperature, pressure and density will help us to determine the different depth. Seismic activity. The shadow zones of P and S wave help us understand the different densities of Earth's layer. Like S wave doesn't travel in fluid. Gravitation, greater at poles and less at equator. Magnetic surveys, determining the magnetic field. Now our journey starts with the crust, the uppermost layer of the Earth, which possesses 1% of the Earth mass. This layer is a delicate like an apple peel, the thinnest layer of the Earth. But crust is not a static and motionless layer either. It is constantly shifting and reforming thanks to the plate tectonics, which are responsible for the formation and displacement of crustal materials. The prevalent rocks which are present in the crust are granite and basalt. Now, here things getting really interesting. Earth crust has two unique personalities, the continental crust and the oceanic crust. And both these crusts are different from each other. How? Let's know about it. The continental crust is made up of calcic intrusive igneous, primarily from a granite, which makes them rich in silicon and oxygen. They are less dense than the oceanic crust. That's why they float at higher on the Earth's mantle, which makes them incredibly thick. On the other hand, oceanic crust is made of mafic, primarily from a basaltic, which makes them dark, dense and volcanic rocks. They are rich in silicon and magnesium. And because of their denser nature, they are incredibly thin, from 5 to 10 kilometers. So, we have two different materials forming our crust, the Asian thick continental crust and young, thin and dense oceanic crust. Now, below the crust, the other layer is a mantle, which is huge 2900 kilometer thick layer, making up of 84% of Earth's volume and 67% of Earth's mass. This layer is not just a big, but also a dense with density 3.9 gram cubic centimeter. Inside the mantle, you will find minerals like olivine, garnet, pyroxene, common silicates. And guess what? Magnesium oxide is a main type of rock here, giving the mantle its unique structure. More discontinuity lies at the beginning of the mantle. It is basically a density contrast from a less dense crust to the denser mantle. Now we know how important a mantle is, so let's break it into different layers. There are three different layers: upper mantle, transition zone and lower mantle. Upper mantle, despite being mostly solid, the upper mantle is more malleable region contributes to our tectonic activities. The thickness lies from 400 to 500 kilometers. The two parts of the upper mantle often recognized as a lithosphere and asthenosphere. Then the lower mantle, also known as mesosphere mantle, it extends from 660 to 2700 kilometers. It is very hotter and denser. The shallow region beneath the lower mantle is known as the D double prime. Now the third layer is the transition zone, which is present at the depth of 410 to 660 kilometers. It prevents the material exchange between upper mantle and lower mantle. There is also the abundance of water in transition zone. But here is the most shocking part is, the crystals in the transition zone hold as much as water as all the oceans in the Earth. Lithosphere is the solid and most coolest intrinsic part, made up of crust and upper mantle with thickness of 100 km and may go up to 300 km. But its thickness is less than 50 km in oceanic crust. Lithosphere has a mantle heat and movement that drives volcanic eruptions and also a movement of tectonic plates. Now the asthenosphere, the hot and soft, weak ductile and semi-viscous region. The seismic waves are decreases in this zone, and it also allowed to flow the lithosphere. Now here comes the core, the third most layer, extremely hot and dense center. The Gutenberg discontinuity lies at the end of the mantle and commencement of the Earth's outer core. This region entirely made up of nickel and iron metal, hence also called as a nickel-iron layer. The 90% of the Earth's sulfur present in the core. The core further divided into two parts, outer core and inner core. Outer core is the hottest part of the core. It is as hot as the sun's surface, which has a 6000 degrees Celsius temperature. It is in a liquid state and has a low viscosity. The Earth's magnetic field is created in the outer core by a self-exciting dynamo process. Magnetic field generated due to electrical current flowing through a slow-moving molten iron. Now, here comes the last part, the inner core, which is in a solid state and mostly composed of iron. It rotates toward eastward but little faster rate than the Earth's surface. Now here comes the most interesting part of this core is, despite having a temperature more than the melting point of the iron, the inner core is still solid. Why? Because of the intense pressure and density due to the weight put on by Earth's top layer, the inner core remains a solid. The boundary between outer and inner core is a layman's seismic discontinuity. Now with that said, I'm going to conclude this video. So, what do you find the most interesting part in the interior structure of the Earth's surface? Let me know in the comments below. Till then, stay tuned and stay curious.